So this is convolution theorem. So this is one of the important topic in the mathematical physics of degree level. Um, so first of all, we will define what is convolution. So before going to the definition, I will tell you about two assumptions. F of s, capital F of s is equal to Laplace transform of the function f of t, and g of s is the Laplace transform of the function small g of t. Here g is the function and t is the variable. G is a function of small t, and f of t, f is the function and t is the variable. So after Laplace transform we get capital G and capital F as a function of capital S, and S is the transformed variable. Well, so now I am defining the convolution of two functions f and g. The convolution of two functions f and g is defined to be integration 0 to t f of t minus tau g of tau and d tau is the definition of the convolution. Convolution of any two function is defined in this way. So first we will start the integration 0 to t, and that t must be here with one function t minus tau, and the subtracted quantity should be the variable of other function g, and this whole integration should be integrated by tau. Okay, so one variable is in the upper limit of the integration and another variable is in the integration variable of integration. Now the theorem states that, this is the statement of the theorem. I'm underlining the statement. The statement of the theorem is Laplace transform of convolution of two function, the two function f and g, is the product of Laplace transform of the function f and function g. The Laplace transform of small f, that is capital F, and Laplace transform of small g, that is capital G. So now I am proving the theorem. I am starting from the right hand side, and that is capital F of s and capital G of s. As for the definition of the Laplace transform, I am just writing the Laplace transform of small f, and that is e to the power minus su f of u du, and with the product 0 to infinity e to the power minus s tau g of tau and d tau. The point to be noted here, that here I am introducing two dummy variables, one is u and another one is tau. The reason is I am multiplying two function f and g, whenever there is a product of two function and if the dummy variable are in the product form, we cannot use the same dummy variable. So I am using one dummy variable as u corresponding to capital F and another dummy variable tau corresponding to capital G. So whenever there is a product form, we have to take care of the dummy variable with different indices. We have to use different dummy variables. Here I am using one variable as u and another variable as tau. So I will proceed for the next step. Here I am collecting two exponential powers and taking common s and writing u plus tau, and f of u and g of u are the rest things to be noted, and du d tau as for the requirement. So it is very straightforward and looks clear that u plus tau should be one variable as for the relevance of Laplace transform. So u plus tau I am taking to be a new variable t, and this gives me u is equal to t minus tau. Du, the differentiation of that u du is equal to dt. So now I am taking care of my limit. U is equal to 0. When u is equal to 0, t will become tau, and when u is equal to infinite, t will also become infinite. So let us come back to our original question. F of s into g of s is equal to tau integration first, that is 0 to infinity, and then the u integration, that is transformed to small t, that is called to t is equal to tau to infinity e to the power minus st f of t minus tau g of tau dt and d tau. Now for my requirement and simplification of the problem, I'll change the order of integration. That means I'll do the tau integration first and do the t integration second. So as you know from the geometry, so this is the line t is equal to tau. That means I am plotting tau in the y-axis and t in the x-axis. X-axis is called my abscissa and this is called my ordinate. So t is equal to tau is just a straight line passing through origin. So this horizontal strip is the change in d tau and the vertical strip is change in dt. T changes from tau to infinity and tau changes from 0 to t. So if I change the order of integration, that means either I sum of all the dt strips first and take the tau all the dt strips, and then I take all the way from 0 to infinite to tau, or I can sum of all the d tau strips and I will find the integration. That means the integration is over this infinite triangle. So somehow I have to cover up this infinite triangle, whether horizontally or vertically. So I can change my order of integration. As you know, integration is nothing but the addition. So we can always change the